I am Anil Kumar. Welcome to my series on trigonometry. In this video, we'll take up four important questions based on sine and cosine law. In case you want to learn from me, you can always send an email to the address given here. Also check our website for the latest edition of our videos. As you learn in this unit, these are the related formulas. That is the sine law formula. A over sine A equals to B over sine B equals to C over sine C. Now this could be written the other way also. Means sine A over A equals to sine B over B equals to sine C over C. The cosine law formula for the sides is A square equals to B square plus C square minus 2BC cos A. Now this formula can be rearranged. So you can bring 2bc cos A to the left side. You get b square plus c square minus a square. And dividing by 2bc, we get the angle A once we find the cos inverse. So you can find the side or the angle using cosine law. Things to remember is that for the cosine law, when you're trying to solve a triangle, we are looking at a triangle which is side, 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 or it is side, angle is included between the two sides. Right? So those are the two kinds of triangles which you're working with when you want to apply the cosine law. Perfect. All other cases you'll be using sine law. We have four examples. The figures indicate the type of examples which we are going to work with. In the first type of example, we'll take up a shape and then divide this into triangles, solve the triangles using sine cosine law, and then find the answer. And then we'll move on to the application questions, 2D and 3D examples to find the height or the distances. Now let's take the four questions, which is a quiz for you. So take it as a quiz, right? So this is a quiz for you. You can actually copy these questions, answer them, and then look into my suggestions. Question number one here is, the perimeter of an isosceles triangle is 100 meters. Find each side if the obtuse angle in the triangle is 100 degrees. First step should be to sketch the figure for the given question and then work out the solution. Question number 2. Find the value of x to 3 decimal places if the figure given below. In the figure given below. Okay. So that is the figure in which you need to find the value of angle x in this quadrilateral. Question number 3. To measure the height of a cliff, a surveyor measures the angle of elevation to the top of the cliff to be 50 degrees. When the surveyor moves 20 meters closer to the base of the cliff on the level ground, the angle of elevation increases by 15 degrees. Find the height of the cliff to the nearest tenth of a meter. Here is question number 4. A harbor patrol officer is standing on a 75-meter lookout tower and sees two boats anchored below his position. The angle of depression from his position to the boats is 44 degrees and 31 degrees. If the angle between the two boats is 110 degrees, calculate the distance between the two boats. You can now pause the video, answer these questions, and then look into my suggestions. Now let's begin with the very first one, which is we are given that the perimeter of an isosceles triangle, right? So the triangle is isosceles, is 100 meters. Find the length of longest side if the obtuse angle in the triangle is 100 degrees. So we are given an isosceles triangle in which one of the angles is 100 degrees. So if one angle is 100, find the value of the other two angles, which should be same since it is an isosceles triangle. So that is our first step. Now, since one of the angle is 100 degrees, it is important to sketch the triangle like an obtuse triangle shown here. Isosceles triangle means that the other two angles are equal, and to find any one of them will be 180 minus 100 divided by 2. So that gives you 40 degrees. So those two angles are 40 degrees. Now we are also given that the perimeter is 100. So if the perimeter is 100, right? So we are given that the perimeter P is 100. So if we assume that one of the side is x, then one is x, the other one is also x, so we get 2x here. So the third side will be what? Well, the third side will be 100 minus 2x, right? So when you add them all, you get your perimeter, which is 100. And that is how we get these dimensions x, x, and 100 minus x. Perfect. Now, once you get the three sides, which are in terms of x, only one variable, we know the angles, we can now apply the sine law to solve for x. So when you apply the sine law, you can write this as x over 400 equals to 100 minus 2x over the opposite side angle, which is 100, sine 100. Now you can cross multiply and solve the equation, right? So you get x sine 100 equals to 100 minus 2x times sine 40. Well, at this stage, you can actually calculate the values of sine 100 and sine 40. Write down the calculated values, then you'll only be working with numbers and find the value of x. Perfect, you could do that. What I've done here, I carried out with sine x, sine 40 and sine 100 till the end so that I could clearly show you the method, correct? So bringing the x terms to the left side to solve this equation, we get x sine 100 plus 2x sine 40 equals to 100 sine 40. So that is a constant, correct? You can take x common and then divide all this term. Divide 100 sine 40 by all this term to get the answer, right? So you get your answer as 28.3 in this particular case, right? So that is how we could get the value of x. Once you get the value of x, you know two sides are 28.3. The longest side will be 100 minus 2 times 28.3, which is 43.4 meters. So we need to find the length of the longest side, right? So that is what it is going to be. So I hope these steps are absolutely clear. Now let's move on and take the next example, which is question number 2. Find the value of x to one decimal place if the figure in the given figure, right? So we changed the question here. We made it one decimal place instead of three. Okay, so that's a small change which I made. Fine. So that is what normally we put angles to one decimal place. Okay, that's fine. So in this particular diagram, to solve, we'll divide this into two triangles as shown here. So the line connecting A to C, the diagonal, converts this quadrilateral into two triangles. Now, if you look into the triangle ABC, we are given two sides and the included angle. So whenever you are given two sides and the included angle, which is the case of SSS, you're going to apply the cosine law. So you can now find the length AC with the application of the cosine law. So which will be what? Square of these two sides, add them up, minus 2 times 6.9 times 7.2 times cos of the angle in between. Correct? So you get this value of AC, which is shown here. Use calculator, get the answer, which comes out to be 5.965. So we got the side AC now. We can check the other triangle, which is triangle ADC, right? So now in the triangle ADC, we can find the angle A knowing the opposite side. Perfect. Again, we are working with SAS situation. The angle is the included angle. Therefore, we will be applying the cosine law. So the formula which we discussed initially and which you all know, right? You all know. The formulas are, if you're trying to work on the sides, in that case the formula is a square equals to b square plus c square minus 2bc cos A. And when you rearrange, in that case, you can say that cos A is equal to B square plus C square minus A square divided by 2 times BC. And then angle A will be cos inverse. Correct? So we have applied this particular formula in the other triangle, which is also SS, sorry, both were SAS, right? Side angle side, correct. So we'll apply this again, the formula directly. Cos x is the two sides now are 7.9 and 6.1, which has been placed as square, minus the third side, which we just calculated as 5.965, and then substituting those values, we calculated the value of x, which comes out to be 48.36, rounded to 48.4. So that is how you can find the angle x. The related formulas are also given here for your reference. Perfect. Now let's look into question number 3. To measure the height of a cliff, a surveyor measures the angle of elevation to the top of the cliff to be 50 degrees. So this is the point A from where 50 degrees angle was measured to the top of the cliff. When the surveyor moves 20 meters closer to the base of the cliff on a level ground, the angle of elevation increased by 15 degrees. That means it became 50 plus 15 degrees. Is that clear to you? Which is 65 degrees. So it has to increase. So it becomes 65 degrees to position B, which is 20 meters away from A. Is that clear to you? So draw a sketch, and this is the height. So that angle at the C is 90 degrees. So a clear sketch helps us to solve the question. Now once you have the sketch, it is not a very difficult question to solve. Well, we have applied sine law in this particular case to solve, but you could also use the concept of right triangles, right? Since we have a right triangle, so concepts of right triangles can be used to find the value of DC, which is the height. But we'll continue with sine law applications, which is much easier and simpler. Correct. Now, when you have these two angles given, and we have given a side here, which is 20 meters, it becomes important for us to find the third angle. So how do you find this third angle? Well, you could do 180 minus 65 and then 180 minus that. You could do like this. Perfect. But the better is that the exterior angle is equal to sum of remote interior angles, right? So use this property. That really means that 65 is basically equal to 50 plus, let us say this is x, right? It is equal to 50 plus x. So what is x equals to? X is 65 minus 50, which is 15 degrees. You get the idea. So that is how we can actually find the value of x, which comes out to 15 degrees. And that is what is shown as our first step. So in this particular triangle itself, find the angle D. That becomes your first step. Once you know D, in that case, you know a combination of angle and opposite side, and you can therefore apply this sine law. We need to find B to D, right? That is what we need to find from B to D. So BD over sine 50 is equals to what is given to us, 20 over sine 15, the angle which we just found. Cross multiply to find the value of BD, which comes out to be 59.195 in this particular case. So once we know the side BD, the other triangle is a right triangle, we can use the sine ratio to find the height since we know the hypotenuse, correct? So apply the sine ratio and find the height, which is 59.159 times sine of 65 degrees. 53.6 meters will be our answer, right? So round it to the nearest 10 to get your answer. Is this step absolutely clear? Perfect. So that becomes an application on 2D front. Now we'll take up the third, which is our fourth example. Here is an excellent application based on 3D. Question here is, a harbor patrol officer is standing on a 75-meter tall lookout tower and sees two boats anchored below his position. The angle of depression from his position to the boats is 44 degrees and 31 degrees. If the angle between the two boats is 110 degrees, calculate the distance between the two boats in meters. Okay, so we have to understand few things. Here's a 3D figure. How do we sketch a 3D figure? Well, 3D references should be like kind of like this. You see that 3D? This is like a corner of your room. Do you see that? 3D figures, if you want to sketch, look at the corner of your room. Do you see something like this? Definitely, these are at 90 degrees. Do you see that? These are at 90 degrees. And therefore, when we are talking about the angle of elevation, if I connect these 2 points, okay, let me just connect them properly. So if I connect these 2 points like this here, then this triangle which is formed is a right triangle, and that is the angle of elevation. Correct. However, we are given angle of depression. So when you are given angle of depression from this particular position, a line parallel to the base. So this is one side of the floor, for example, or the ground. We have to draw like this, and this is the angle of depression. So this is the angle of depression. Is that clear to you? Now these two angles are equal since we are talking about parallel lines. So that is what is shown here. Now these two lines are parallel, and therefore the angle of depression is equal to the angle of elevation. So we get 44 degrees angle on one side and 31 degrees angle as shown here in the diagram on the other side. The police officer is 75 meters above, and therefore the height here from P to O is 75 meters. And these are the two positions of the boats A and B. Angle between them is 110 degrees. So that completes the diagram. And this is the most critical step. So get your diagram right. That is the first thing. And this is such an important diagram that you should make a note of it. It fits into 90% of your 3D questions. So make a sketch like this handy for fitting in the values given to you for a 3D question like this. You get the option, correct? Now, let us see how to solve it. Now, in this particular case, we really want to find the distance from A to B. But we cannot start with this triangle since only thing given here is the angle. Right. So what are we going to do? Well, it's a good idea to find the length AO and OB. Well, these will be in terms of the height, but we can find them for sure. Once we have these two sides given to us, then we can find the third side using cosine law. Correct? That is the whole idea. So the first step is solve these two triangles which are in the vertical plane. So solving this, we can use the trigonometric ratios since these are right angle triangle. Does make sense to you? So this is a right angle triangle. And therefore, tan of 44 is opposite side over adjacent, which is 75 over AO. Now cross multiply to get what AO is. AO 75 over tan 45, which is 77.66. Similarly, tan 31, the other triangle, gives you the length of B2O, which is 75 over tan 31, which is 124.8. Now, in this particular case, we know two sides with an included angle, and therefore we are going to use the cosine law. Is that clear to you? So using the cosine law, we know the length AB will be square root of square of these two lengths, right? Minus 2 times these two lengths and cosine of the angle in between. So that included angle 110 comes here. Once you calculate, you get this answer to be 168 meters. Is that clear to you? Perfect. So that is how we should be answering these questions. Once again, these are important formulas to remember whenever you're working with sine law and cosine law. Another thing, if you have a question, then it is very important to sketch. We have also shown you how do we sketch 2D and 3D applications. Those are very handy at times when solving questions. I hope it makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and
All the best.